So the other day we were playing around with matrix multiplication, and you found out that some matrices you could multiply together and some you couldn't. We've already seen that if you add or subtract matrices, they have to be exactly the same size, but that's not true for multiplying. For multiplying, we say that the two matrices have to be compatible. And what that means is, in order for it to work, the columns in the first matrix have to be equal to the number of rows in the second matrix. And that's just the start to find out if we can multiply them. So if we have this value equal to this value, that tells us that we can multiply them. So the columns of that first matrix and the rows of the second matrix have to match up. If that happens, then the outside values become the size of the answer. So first of all, we're checking if the columns and the rows match up to see if it's possible to multiply. And then, if it is possible, we can use the outside dimensions, the rows of the first matrix and the columns of the second matrix, to find out the order of our answer. So now we know if two things can multiply, and we'll know what the size of the answer is. We just don't know how to put the numbers inside of them yet. So we'll do an example. So this matrix right here, this first one, is 3 rows, 2 columns. And the second one has 2 rows, 1 column. These middle numbers are the same. So when we multiply these together, we're going to get a matrix that is a 3 by 1 matrix, because those outside numbers will be what tells you your final answer. So this one, okay, the middle 2 numbers are equal, yes, so we can multiply these matrices. This one here, this is a 2 by 2, this is a 1 by 3. If we look at those dimensions and we check these middle numbers, they don't match, so they can't be multiplied, and these ones you couldn't find an answer for. Rule 2, if you can multiply them, then we know the size, and we talked about this before, that this would be a size of a 3 by 1. We don't know yet how to get these numbers inside. How do we get 23? How do we get 53? How do we get 83? But we do know the size that it's going to be. So now, to get those answers, what we do is we multiply rows by columns and add. So we're going to color code this. When we look at our answer has 3 elements. It has, this element would be, let's call this matrix M. This will be M, row 1, column 1. This one will be row 2, column 1. And this answer is row 3, column 1. So if we itemize each of those that way, we can talk about where those answers come from. And those answers come from the following. If I want to get this 23, it's in my answer, it's in row 1, column 1. So I need to take row 1 and column 1. Ooh, I'm going to make a graphic here. We'll see if it actually works. Okay, so 1, 2. Okay, let's see how much of that is connected. Oh, nice. All right, you ready for this? So, the idea is as follows. Row 1, you can imagine it rotating, coming like this, slam, oh man. We just had a, okay, here we go. Here, come on. There we go. Slam. try that one more time. Here we go. Slamming into the 7 and 8. So the 1 hits the 7, the 2 would hit the 8. You multiply the numbers that slam into each other. So we have that right here. The 1 hits the 7, the 2 hits the 8, and whatever you get from that multiplication, you add it up, and that's how we get the 23. Okay. So now, for our second one, we'll color code that one in blue. That one in our answer is in row 2, column 1. So to get that answer, we need to take all of row 2, all of column 1. Notice that the column 1 is the same column that we had before. So we take these two answers. Again, we rotate them and slam them into that 7 and 8. The 3 hits the 7, the 4 hits the 8. Again, I'll underline that one in blue. And then add those two up, and we'd get 53. And finally, if we want to get this 83, well, that comes from row 3, column 1. Oh, that's not what I wanted. Well, slam. And the 5 would hit the 7, the 6 would hit the 8. Add them together, and you'd get 83. So this one only had 3 calculations to do, but sometimes you have quite a bit more depending on how big your answer is, how many rows and columns you'd have to multiply together. Yeah. Is what's supposed to be read? This? I hope so. But I would be a little nervous. So if you had a 1 by 4 by a 4 by 2, those could be multiplied together, and your answer would be a 1 by 2. These ones you couldn't multiply together because the middle numbers don't match. But if you switched them around, if you decided to multiply the 2 by 2 by a 2 by 3, then they could be multiplied together. So the order that you multiply things does matter and can affect the answer. So here are 6 for you to try. Here, I'll put up all the answers for you. Maybe, maybe not. There's one. Oh, there's another one. There we go. Oh, no, I slipped them. All right, so we have some properties that result in matrix multiplication. And one of the things that we noticed, if we go back to this and put all of our answers back up, we did A times B in A, but later on we tried to do B times A and it didn't work. Because when you do B times A, by putting B first, which is our 2 by 3, and multiply that by A, which is a 2 by 2, these middle numbers now don't match. Now in mathematics, when you learned that 5 times 7 was the same as 7 times 5, there's a name for that they never taught you, but that word is commutative. So if you can do something in one order, multiplication 7 times 5, and it works out that that's the same as 5 times 7, that's a mathematical property saying that it normally is commutative. But in matrices, that doesn't hold up. And so if we look at some properties and learn some other language for mathematics, we've got the word commutative in the first one. We found out that that doesn't happen. We did find out that it was, well, in one example, and I'll tell you now that it does work for all examples, that multiplication is associative. That means you could do the AB first or the BC first when you're multiplying 3 things, and it will still work out as long as you multiply A times B and not B times A. Yes? B times AC. Well, then you're doing this, right? So then you're doing step one, you're switching the A and the B around, and that won't work. Multiplication is distributive, meaning that if you wanted to, you could either add B and C up first and then multiply, or you could multiply A times B and A times C and then add them all up together. Recommendation, what's easier, multiplying or adding? Adding, so add them first, right? Because that would be really quick, and then you just have to multiply once. Otherwise, you'd have to multiply twice, which is a lot of calculations, and then add them up in the end. There is, in multiplication of identities, a multiplicative identity, meaning you can multiply by 1 and then it equals the same thing. Do you remember seeing the identity matrix earlier in our notes? Do you remember what it looks like? What would a 3 by 3 identity matrix look like? Here's a 3 by 3. Yeah, the main diagonal has 1s, everything else has 0s. So what would happen if I took that 3 by 3 matrix and I multiplied it by 1, 2, 3? This one is a 3 by 1. How big is my answer going to be? It's going to be a 3 by 1 as well. And what happens? Well, you take row 1 and multiply it by column 1. Do you see that the only number that gets hit is the first number with a 1? And so you get 1. And if I take the second row and multiply it by the first column, the only number is the 2. And then the 3. And so this identity matrix is like multiplying by 1. So we want to have the number 1 exist for matrices. This is what it looks like. So when you multiply by that, you get 1. Or you get the same answer that you started with. Now, when I multiply this way, I have to have a 3 by 3 first. If I multiplied it the other way, this is my 3 by 1, what would be my identity matrix here? How big would it have to be? A 1 by 1. Whew. Okay, and what do we get? We still get 1, 2, 3. It still works out. But your identity matrix might be a different size depending on which side of your matrix that you multiply by. So that's important. And we also want to find out about an inverse. So if we multiply a matrix by its inverse, we're going to get 1. So we want to find that inverse. And that's another thing mathematically that we're going to do going forward.